So today I'll be discussing about some concepts like Spark performance tuning, DAG, Spark GUI, broadcast variables, accumulators, Hadoop batch and Spark real-time process, and some limitations of Apache Spark.
Vijay sir, can you add one more topic for troubleshooting a Spark job? Just to go through how to click and how to understand the different containers and whatever. It's so very confusing.
That we have discussed, right, in the previous
Did we?
topic.
Sorry, I missed some of the classes. I was traveling.
So I guess
So
we had a lot of discussions on this, right?
okay.
Drivers, executors, narrow transformations, wide transformations, submitting Spark jobs, right? What are the parameters, many parameters, where how we provide, what are the various configuration parameters, lot of
Okay.
discussion. You can just go through that videos, right?
Good. But did you went through like if you submit the job, how to trace the job from the resource manager, and then how to go to the Spark history server and look for job and look for how the progress is happening, what it is executing, type of things.
How internally it's going to be processed, you are talking.
Yeah, basically what happens is sometime, most of the time the job fails and a lot of people have no clue where to search and how to look for to find the actual cause of the issue from the Spark job history, Spark history server or the resource manager. So I just wanted to find a way of at least one job, any one Spark job, once it's submitted. I think most of the companies I've seen there they submit the job, it goes to the resource manager, and then resource manager allocate whatever it has to, and then the job starts running, and then you can see the progress in the job history Spark history server. But then Spark history server keeps on invoking multiple containers, and it's very confusing. this,
Instead
that's
of,
where I know I try to see the YouTube videos, but nobody has explained me very well that part, like how my job is going through, and and if I have to troubleshoot, how do I troubleshoot that?
okay, okay, let's see.
Sure, and whenever you have time,
Yes, okay.
that will be really helpful. That's one thing I'm really trying to understand, and means I do it, but I still don't have a full baked knowledge of it. So
So
Yes, even I am expecting that one, Vijay.
yeah, what is it?
The same thing I am also expecting.
I didn't get you.
No, the same thing, whatever Anil said,
Hmm.
even I am also expecting the same.
Okay. Okay, so here performance tuning in Spark, correct? See, I was just okay. Whenever Spark, whenever you launch a Spark application, right? I said, see, previously I was discussing, right? Okay, this is your Spark application. This thing we discussed all this what you have said, right? Spark application. When you launch a Spark application, Spark driver gets created. Here, these are your nodes, worker nodes, worker nodes, worker nodes. Here, worker nodes are there. Here, for example, slave 1, slave 2, slave 3. Here, for example, B1 block, B2 block, B3 block. So from the blocks partitions created P1, P2, P3 partitions. Okay, a Spark application that when you launch Spark driver program. So driver program, see here, partition 1, partition 2, partition 3. Your data is divided into partitions. Driver program is going to allocate logic to each partition, is going to allocate partition to each. What is that logic? Who provides logic to the partitions? Nothing but a driver program. And driver program, that is what driver program assigns partitions, and partitions with the allocated logic is taken care by executor. So driver program, when it allocates logic, that partition along with logic is taken care by a executor one. For this, one more executor. For this, one more executor. So only one driver, multiple executor. So executor, okay. So this is what we call it as a task. This we call it as a task. It's a state. A task is a state. So here, this we call it as tasks. How many tasks means number of tasks equal to number of tasks equal to number of executors equal to number of partitions. Number of partitions. Number of tasks are executors here. Generally, your partitions, data divided into partitions. Partitions, see, driver provides logic to each partitions. The execution of these partitions along with the provided logic is taken care by a program called executor. So execution of these partitions we call it as a task. Number of tasks equal to number of executors equal to number of partitions. And here, depending upon what kind of transformation you are applying, transformation, is it a narrow transformation or a wide transformation? Here, narrow transformation or wide narrow transformation means no shuffling of data. Here, wide transformation means where shuffling of data. So when shuffling of data, no shuffling, right? No shuffling, up to that shuffling. For example, from transformation 1, transformation 2, transformation 3, so keep on transformations, right? So it is a data flow language, right? Spark is data until no shuffling. We call it as a stage 1. Whenever shuffling occurs, wide transformation, that we call it as wide transformations. Then from there we call it as stage 2. Means from there onwards, stage 2 until the next shuffling happens. Shuffling of data, that is up to that stage 2. Next shuffling happens, there onwards it is stage 3. Stage 1, stage 2, stage 3. So in the same way, this is what narrow transformations and wide transformations. This we call it as stages. This we call it as tasks. And these drivers, executors, Spark applications, providing logics to this. So this everything, if you are running, I also discussed about yarn process and local process. When you're running on this yarn, right? Yarn process. So first it will be given to the resource manager. From there onwards, so partitions are created, they are stored, and whenever driver program is going to take care about all this, right? Execution process by creating multiple executors, n number of executors for n number of partitions, n number of tasks. Yes, these things in detail I explained, right, in multiple sessions. Once again, you can go through this, right? And Spark performance tuning. Okay. So I said by default, Spark is going to take, by default, Spark takes some default configurations, but still if you want, you can increase the configurations, or we need to set our own configurations, right? In the case of performance tuning, by default, if you're not, whenever you are submitting Spark job, right? If you, all that configuration parameters are optional, but optional, I said what would be the default course, default executor memory, driver memory, what is the default memory, it's everything I said, right? But even we can set our own memory, and how to calculate the cluster memory also, I said what is the required things, how to calculate the cluster memory. So depending upon that, we are going to adjust the settings to record for memory cores and instances, right, used by the systems. So we call them as tuning. See this Spark as optimal performance. So it has got some effective changes are made to each property. So in the case of memory computations, right? Sometimes to decrease memory usage, RTDs are stored in serialized form. Sometimes to decrease the memory usage, RTDs we are going to store in serialized form, right? So here, okay. What is this? Let's see. So here in performance tuning, I can say three things. Data serialization, memory tuning, and memory management. Data serialization, memory tuning, and memory management. Again, in this memory tuning, if you talk about this memory tuning, again we have got two things. Data structure tuning. Garbage collection tuning. Okay. So here first thing is data serialization. So as I said, right, sometimes we are supposed to decrease the memory usage. So in serialized form, data serialization is going to play some vital role here. So it is also, this serialization is also going to help in reducing memory usage. What do you mean by tuning? For example, eliminate those jobs that run long. Improving the performance of the time of the system, right? So data serialization, if we talk about this, first thing is what? Data serialization. So here, what is that main data serialization here in the performance tuning, right? Yes. In memory object is there, right? Whatever in memory object. So data serialization, right? Process of converting in-memory object to in-memory object to another object to another format. In-memory object to another format. Another format means that can be used in file and send over the network. Converting in-memory object to another format that can be used in file and send over the network. So here in this kind of data serialization, right? It's a distinctive role, right? In the performing and distributing the application. Okay. So, but okay.
Vijay, can you explain this sentence? I'm little confused. In-memory object to another format used in file.
So I talk about we have discussed previously, right? Persist options.
Yes, yes, yes.
In memory, you are persisting, in disk you are persisting, right?
Yes.
So if unable to persist in the memory, you are going to convert into byte format, object format to byte format. So this is nothing but the same thing. You are converting memory for object to another format like byte format. So what you are going to get means it will going to occupy less memory. Yeah. So I mean that amount of memory used by objects, the amount of memory used, the entire data should fit in the memory. Okay. Okay.
So here another format means like
Byte format.
byte format. Okay.
So
Like we are also something we are giving the format, right? Like converting zip, like something either what kind of zip.
so that is for dependencies. If you want any kind of dependencies, right, we will be just going into the zip format. When you are submitting, you are creating Python file, along with that some kind of dependencies you are going to provide in zip format.
Okay.
So here, so another thing is, right, here, see the second one. See, the first one is data serialization, means converting in-memory object to other format like byte format, right? And the second thing, memory tuning. Memory tuning also the same thing. Memory tuning or data serialization, nothing but, for example, whether you want to persist, my job need to execute. My job should not be failed. So in such case, we can give that options, memory and disk options. So if memory is free, okay. Otherwise, into serialized format, converting into some serialized format. Otherwise, just giving the options like memory and disk options, so that finally my job need to be executed. Otherwise, once the memory is free again, from disk to again, it will be shifted to memory. So first thing is all related to memory issues. Okay. Spark data structure tuning, right? Spark data structure tuning. So data structures tuning means wherever you see nested structures, we need to avoid the nested structures. Data structure tuning means in creation of while creating RTDs and for performing transformations, right? Avoid the nested structures with a lot of small objects. And also some kind of instead of using strings for the keys, just try to use numerical IDs. So we'll see like key value pairs, right? Key value pairs. Instead of using strings for the keys, use numerical IDs. Okay. So the mainly thing is here in data structure tuning, if you have got a lot of nested things, right? Try to eliminate those nested structures. And if any types of keys which are in the string formats, other things, right? If there is any chance, try to convert into numerical IDs. So if okay, I'll come back to this garbage collection tuning. But in the memory management, right? Execution and storage, Spark storage and execution, right? Memory management in the sense means you need to store and execute, right? Storage and execution.
Yes.
So in such case, memory management means even which involves shuffles, joins, aggregations, right? So in this, we are going to have some data getting shuffled, data is joins happening, aggregations happening. So accordingly, and also, yes.
Vijay sir, is there any program or software available where it can parse my Spark program and see if there is any improvement or suggestions for the data structures, what is defined?
Any program or application?
Any software available which can parse through my program and see if any data structure which I have defined inside the program can be still, tuned better or suggestions or recommendations.
No. Actually, programmatically, so
Yeah.
that is practically, right? Practically or programmatically, how we can change these things, right? So everything done by the developer, right? In writing the code, only that, but we doesn't have anything. But how we can improve means what to be used, what not, what we need not to use. Those everything we will be discussing here. Performance tuning means just in what way, by writing the code itself, right? Which functionalities to use, so that
so basically these are the guidelines for writing the program.
Yes, that's what, right? That's what
Yeah, got
so finally,
and ad hoc performance tuning, you have already taken care of it, correct? Like changing.
Spark has already provided you many options. While submitting the job, you are going to provide configuration files already.
Correct. Those can be ad hoc changed,
so
but this cannot be changed once it is written. We have to rewrite the code. Okay.
Yes. The thing already mainly some optional configuration parameters are there. If you're not providing all this, right, by default Spark takes something and it will just even though by not providing any of this, right, while submitting Spark submit, just you can provide your command line arguments, right? Input file, output path, and the program path, everything that you can provide, and directly Spark can execute. Spark takes the default in default parameters. It takes that executor memory, driver memory, or course, everything it takes by default. But one thing, if you want better performance, you need to set that. We need to use it. That we need to set that properties. We need to give the configurations, everything along with it. That's why we call it as optional configuration parameters. Many are there. So we have discussed those all parameters, right, previously. That we can view apart from this some way where in this memory point of view also, if you want any kind of these things, we can That's what I'm discussing, right? Data structure
Yeah.
tuning is complex operation. See, when the execution memory is not in use, execution memory is not in use, the storage can use all the memory. When the execution memory is not, you see, I said two types: memory management, execution, and storage. When execution memory is not in use, the storage can use all the memory. I said previously, RTDs, already RTD is running in the RAM. The RAM is busy. Next, if I triggered a job, now the RAM is already executing other thing. It's already in the execution, right? RAM is busy. RAM is busy means I cannot use the entire RAM memory, right?
Yes.
Okay. So understood, right? Execution memory is there, storage memory is there. So if execution is not in the progress, it can use the entire storage memory, right? So
So Vijay, can you explain execution not in use and storage can use all the memory? I mean, not
both
visualize.
both execution and storage use a unified region. When the both are using the unified region, right? So execution memory is not in use. Execution memory is not in use. Okay. Execution can drive out of the storage if necessary. Okay, just nothing but internally, which all these things which you cannot be seen, right? But you are processing a RTD, right? You are processing an RTD
Yes.
within the RAM. So while processing the RTD, right, immediately, okay, simple, very simple RTD. My RTD size is 5 GB. My RAM capacity 5 GB. Assume RAM is 5 GB, but RAM is processing other RTD. RAM is processing other RTD means this RTD cannot fit into the RAM, right?
Yes.
Your total RAM capacity, assume it is 50 GB. 50 GB about all the RAMs if you take. Total RAM capacity of whatever systems you got. 50 GB, but your RTD GB also 50 GB. Now, otherwise, whatever it is, but your RAMs are busy computing other RTD or other things, right? Means already they are processing other thing. So here in this case, right, this RTD cannot fit into the RAM. But after this executing, that this is the execution process, but after some time execution finished, this RAM is totally free, right?
Yes.
Now it can fit into this. It can fit into this memory management, right? Memory management within this Spark. So if you give memory and disk option, if you are giving memory and disk option, immediately after it is processing the disk, immediately this RAM is free means okay, it will be again stored in the RAM and it is processed. When I said when it is not in the processing state, now the entire thing can be used for storage, right?
Yes. Yes.
Entire thing can be used for storage, right? 50 GB I can use entire thing for storing the data. Okay. So for example, if my RTD size is the only 3 GB, but here 8 GB available, my RAM capacity 8 GB, even it is processing other RTD of 3 GB, still this RTD can fit into this, right?
Yeah.
This RTD can fit into this means even though it is in the execution process, even there is some 5 GB free in this. So it can fit into that. Okay. So even
Sir, this is what I'm looking for when let's assume I'm doing a troubleshooting process, correct? So multiple, it's a shared environment, multiple jobs are running on the same node, and if my executor is already in a running status, but in the different stages, it loads an RDD which is a bigger size and it cannot fit in the memory for that node. So it's going to wait and wait and wait for the memory to free up. So my executor is still in a running status. It has not failed or did anything. So what action the executor will take?
okay.
Either it will think that there are no memory is going to be available, so it's going to take that RDD out and re-execute the whole process from the stage one to a different node, or how long it's going to stay there. So those type of how do I check something like this? I'm looking for troubleshooting like that to understand that why that executor is waiting. It's not giving error, but it is still waiting for something. So how I catch those type of errors?
Executor is what? Is a physical or logical component?
It's a logical component, correct? It's a
Executor
container.
Executor is a logical component, right? It's a
Yes,
kind of program.
correct.
Yes. Just somewhere I explained this previously. I was looking for it.
And I'm sorry, sir, I have missed it a lot of classes. I was traveling, so I'm sure you must have told it, but as if it is doesn't take much time, just a 5 minutes recap.
So here, yeah, application one utilizing, right? So many examples I've given previously. So application one utilizing 1 GB core, system 1 GB core, system 2, 1 GB core, system 3. So each system has got 8 GB and 4 cores, memory and cores. 7 GB means application one, my first application, it is utilizing from system 1 GB and 1 core. RAM, 1 GB RAM and 1 core. From system to 1 GB and 1 core, 1 GB and 1 core. So out of, but each system has got 8 GB and 4 cores, right? Each system has. So means 7 GB memory free in each system and 3 cores free. Because here it is using 111 for the application one and 3 cores free, which can be, means 7 GB free and 3 cores free, which can be used for other applications. So here application 2, the second application, it is using 2 GB and 2 cores, 2 GB and 2 cores, 2 GB and 2 cores, right? 2 GB and 2 cores. Okay, system 1, system 2, system 3. So here all this, so if still 5 GB is left out and 1 core is available for the other applications. Now I can allocate 5 GB and 1 core to application 3. Still application 3, I have what 5 GB and from each system 5 GB I can allocate 1 core to application 3. Means we, while submitting, we can provide these things, I'm saying.
Got it. But these are the parameters for the executor size, correct? 2 GB and 2 cores is the size of your executor. It will have that size. But now,
so I said in order to allow multiple apps to run on a cluster, it should be submitted to fair scheduler.
okay.
FIFO and fair scheduler supports two schedulers, FIFO and fair. So here we need to submit Spark application, means 2 applications can be submitted until first application is totally executed. It won't allow second applications to be submitted in the case of FIFO until first application is totally executed, right? Means there is one application can run at a time only, but to run multiple applications, go for fair mode. Okay. So one second, if I have got this, don't know, like one second, let me open this Hadoop. So here in my terminal. Let me open the browser. I think which browser? Chrome. I don't know whether Chrome available in this. Let me start the services first. Control Shift T. PySpark. And one more thing, yes. Okay, I'll come back to this. Prasad Mohanty, right? You were saying sometimes in your Jupyter notebook data frame created, sometimes it's not.
Yes, yes.
So here one thing, in your Jupyter notebook, right? Yes. So first, generally in Windows, right? First Spark. Okay. Second is Java first. Next Python. First Java. Among all these, right? First Java should be there, right? Second Python. Third Spark. You need to download like, so already Spark 1.8. Java any version above 3.6.
Java, you have sent a zip file 1.8, that one JDK, right?
No, JDK 1.8.
Yes.
Spark, any like Spark 3 version you are using, right? So while selecting Spark 3, right? So there are some Chrome. Actually, stable versions. One second. Spark download. You say. Whenever you say Spark download, so choose a Spark release 3.3 or 3.3 or 3.2. Anything you select, right? Selecting. Okay. Try to select the stable versions of Hadoop, right? Go for Hadoop 2.7. Go for Hadoop 2.7, right? So 3 versions, there are some problems in Hadoop 3. Still, they are not, some of the versions are not stable versions. And here, while installing Spark 3.3 and Hadoop 2, Spark 3.3 and Hadoop 2, just click it and just install it. Once if you see this, your download will happen. So once you see in the C drive, right, you will get extracted file. You will get this, and I'm keeping within the C drive. And in C drive, we need to okay, give the environment variable path for Python, for Java, and for Spark. Environment variable setups. Yes, environment variable setups and path setups. There will be two types of setups. So here, if you are just copying this, Spark path is nothing but environment path.
Okay.
Environment, just what is your, where your Spark is available, that is environment path, and where your bin is available, and where you see all the .exe files, Spark submit, Spark SQL, all this, right? Spark submit. This is what your path. Spark. Okay, environment path is that, Spark path. So here generally what we do, wherever you install Python, wherever you install Java in your system, right, we need to set 3 environment paths: one for Spark, one for Java, one for Python. So just observe this. If you go to this in the search env, I'm saying to go to the environment variables, just say env, environment variables. So here 3 things, if you see: Hadoop home, Java home, Python home.
Okay.
See 3 homes.
Hadoop home, Java.
Python
Okay.
home. Hadoop home is nothing but the same Spark folder only, because both Spark and Hadoop combinedly, right? We have taken Spark 3 version, Hadoop 2.7. While extracting, we have selected, right, what is the
Yes.
Spark version Hadoop. And Java home means where Java is available, and Python is where Python is available. And these 3 you can give. This is what normal environment variables path. And a path variables, if you go to the path, right, for all this you need to give the bin path. For JDK,
Okay.
bin path. For Spark, bin path. And for Python scripts, there won't be any bin folder. Scripts we need to give, right? So that's fine. But later to work properly, right, to work Spark proper, so just we need to go for so just you say WinUtils. We need to download WinUtils. WinUtils for which Hadoop version? WinUtil, we have downloaded Hadoop 2.7, right? Okay, for otherwise just say WinUtils. Click WinUtils, right? Binaries for Hadoop versions. Okay, you can just select WinUtils. And here, whenever you click WinUtils, what is the version of Hadoop? What is the version of Hadoop? 2.7.1 or 2.7 version, right? Here 2.6 is there, 2.7 is there. Select 2.7. In that select 2.7, right? Yes, in that bin is there. In that bin is there. In that bin, check for that WinUtils is there, right? For
Yes.
2.6 and 2.7, this for, okay, WinUtils. Click this WinUtils. Download this. It's just 107 KB, right? Download.
Okay.
It will be
Okay.
download. After downloading, bring it and paste it in the bin folder of Spark. Bring it and paste it in the last, you can see WinUtils, right?
Okay.
So bring it and paste it in the Spark folder. Now we can work with this, right? And next thing is find Spark. We need to find Spark, that is compulsory. That module need to be installed within the Jupyter, right? Already.
Yes.
in that, and if you go with that, you won't get any type of errors, right? WinUtils. You can this WinUtils. This is we need to download and we need to keep within this Spark folder. Whenever Spark finds Spark, right? Whenever it is finding the Spark, along with the Spark, we have got this WinUtils available in this, right? Can execute in that, right? And 1 second here, within this, I'm minimizing all this. I'm minimizing all this, right? Here, Chrome browser is there, right? Chrome browser. Localhost. If you want to see all the environment variable, localhost. Spark shell, Spark jobs. So here PySpark shell, PySpark shells, PySpark job status. So actually, if you have executed any, okay, today I didn't execute anything, right? Yes. Okay, executed, see here, but yesterday, or day before yesterday, if you have seen added executors, jobs, these things, right? You can see here, stages. But if you have done some task, it will show all that recently what all the jobs, their status, everything. What are the jobs which are recently completed? Stages for all the jobs it will show. Storage. Environment means it will show all the environment variables, right? What all the environment with Java version is 1.8. Java home is this. Java Scala version or Scala properties. All these environment variables, system properties, Spark submit, all the environment variables, everything we can see within this, right? So it is a GUI for Spark. System class paths for all this, right? Hadoop ecosystem, Spark, bin folders for all this. Executors. It loads the executors. 1 second. SQL. Once if you have done any jobs submitted and jobs got executed, right? You can check in this. Fine. Now,
Vijay, where you are getting the Mozilla? I mean, this Mozilla. I'm not getting any VMware. Where is the option?
What is it?
Mozilla Firefox. You are opening GUI, right?
Yeah, for Firefox also you can open in that.
Okay, here. Okay.
In the Firefox, just say localhost :4040. Mozilla, actually Chrome I have installed it.
Okay.
So here, SYFT software updater will be there. You can see if you see software updater, if
Yes.
you want, software updater will be there. Sorry, not software updater. No. Please be in mute. Software, just say software. Software, you say. In the software, all the installed ones means it will show all the installed one. Installed ones. What all the things got installed. Here search is there. In the search, Chrome you say. Google Chrome if you want that. If you want to install Chrome. Say enter. So here chromium, right? You select it. So it will show you that status. It's already installed. Otherwise, you get install option. Click that install. It will get installed. You can go to the software. You can select which software you want to install within this. Click it and install it. It gets installed. I think you have got only Chrome in that. Sorry, Firefox in that. You want
Yes,
to
yes, yes. This GUI for Spark only localhost :4040, right?
yes 4040 yes.
Okay.
Now if you talk about, yes, last time you were asking about something about DAG, right?
Yes.
DAG. Directed acyclic graph. Directed acyclic graph. So it's any graph, right? So DAG in Spark. So any graph, it has got edges and vertices, right?
Yes.
Set of vertices will be there and edges will be there. What are these vertices and edges? Vertices means RTDs. Edges means operations, transformations, or actions. So here vertices means RTDs, edges. Okay, 1 second. See this. For example, R1. So it's a vertex, and you'll have some edges like this. Operations. Operation on the RTD, operation on RTD as a transformation or action, right? So here edges represents transformation operations, with the operations or actions, right? Yes. So here on calling action, when action encountered, whenever action encountered, only the entire flow gets executed, I said, right? Data flow gets executed.
Yes.
When action encountered, the created DAG. So in this way, you will see RTD vertex, RTD edge, RTD edge, RTD edge, RTD edge. Okay. It is what acyclic, not cyclic. You won't see any closed loop here. You won't see any circular or cyclic. It is always, it is not a closed loop. RTD1, RTD2, RTD3, RTD4, like vertices, nodes, and edges will be there. When action encountered, the created DAG scheduler will be there. The created DAG submits to DAG scheduler. What this DAG scheduler does? Further splits the graph. Further splits the graph into stages and tasks. Into stages and tasks. The DAG scheduler further splits the graph into stages and tasks. If we see an example of this, right? For example, assume this is stage 1. Stage 1 means first what you will do? RTD parallelize first. After parallelizing, next I will do some filtering operation. I'll perform some filtering operation. Next, after that, I'll perform some map operation. This what? Stage 1. Parallelizing, filtering, and map. So next, what happens? This output. From there, if I perform reduce by key, data gets shuffled, right? Reduce by key means data gets shuffled. Yes or no?
Yes.
Reduce by key means all the time. Reduce by key and group by key, how it is going to run within the cluster, I said.
Yeah.
Reduce by key all male partitions, for example, into one, all female into one part. So shuffling. Okay, here stage 2, right? Stage 2 starts. Again from there, some map operation. Again from map operation. Again from map operation onwards, you can take this map, whatever the map output. Some join operation I'll perform. Join. Whenever you perform join, right? Again, one more stage, stage 3, right? Stage 3. So understand this, how this graph, stage 3, join. Again, join. Again, some operation. Again, some operation. Again, from here, stage 4. Some operation, right? In this way. Means in the same, okay. Stages are created, stages and tasks. First, what is the DAG scheduler? First, we submit, okay, RTD send operations, RTD send. On RTD, you performed operation pair, you got filter, again filter on that map. So here, just observe this diagram. Assume stage 1, parallelize. Parallelize, in that again filter, map. This is taken by reduce by key. Reduce by key means again stage 2. Again from here again map operation. Again from this again join operation. Again some operation you perform. Again some operation. Again from this is stage 3. Again stage 4. Some operation, again some operation. Some in this way, right? So stages are created. Stages are created until data. If data is shuffled, right, a new stage is created. Means until if all the RTDs are within the narrow transformations only, then it will be within the same stage. DAG is a graph with directed graph. It's a directed graph with no cycles. So you won't see, you never come again to R1, R2, R3, R3 or R4, but you cannot get a closed one like this. It's not, you won't get a cycle like this. Again, R4 to R1 you never get. Again, you never go to R1. This is what cyclic. It's like a cyclic. Again from R1, R2, R4. Again from R, no, it's acyclic. You cannot go to R1 again, right? So it will, there won't be any closed loops. There won't be any cycle. So it's a, so generally this is taken from the, it is a generalized format from, it has taken from MapReduce only. DAG operations can do better. Go, let's see, any kind of optimizations. Okay. So here Apache Spark, the Spark is going to, Spark DAG allows the user to divide into stages and expand on detailed way, right? Stages, stage view. Understood, right? This one, DAG style.
Yes. But in GUI, how you can see that? I mean, DAG, there is a DAG also created when you submit a job. But if a job fails, you can see in the DAG also.
Yeah, anything you can see in that GUI, right? In that GUI, if anything, any fails happens, everything, it is going to, whatever, everything job related, everything is going to be shared in the GUI. Okay, once any, you can just check it, right? If any time when you are, if you got some error, you can check it there, right? It displays. See, okay.
Sir, in the next session, maybe if we can run a little larger job, and then we can in-flight job, we can go and check all the stages and see what's going on, and you can give us some hints, and that will help to understand everything. Because it's a when you open a job, there are many tasks and each task has so many logs. It's very difficult to know what it is doing, and yeah, it's just the concept wise.
See, when once you should have seen, right? Stage. When you are, whenever you say df dot show, if you have observed in our example, stage, and finally it will display the table. You have observed or not? Whenever you are submitting anything, at the time, many times you should ask stage 1, stage 2, stage 3, like that.
multiple stages. Yes.
multiple stages, and finally it is going to display your table, structured table, data frame. Data frame is going to be displayed, right? Yes. Okay.
But in GUI, you can show once. I mean, maybe next class, you can submit a job and we can see.
Okay, fine. So who are going to execute? Okay, generally the slave nodes will execute the task, right? So number of tasks always depends on number of executors. Number of executors depends on number of partitions. Okay. Okay. For example, job execution, how it happens within Spark. So as you asked, I'm not saying anything about yarn here. Already you know about it, but I'm not discussing anything about that yarn. So here first, whenever you launch a Spark application, two programs will be okay. Driver program, right? Driver program.
Yes.
Okay. For example, driver program. Spark session will be created. Spark equal to Spark session dot get or create. You say okay. RTD equal to, next you will say RTD equal to okay, RTD creations, RTD dot RTD 1, RTD dot 1 dot filter, RTD 2. Okay, RTD dot collect. Don't see, generally in most of RTD dot take, you say RTD dot count, you say take 1, take 5. So whenever you say action, whenever this is what action. See, so this driver program here, cluster manager. Cluster manager. So how you are giving while submitting only, you will give whether it is local mode or yarn. So a cluster manager allocates the resources and instructs. So here, okay. So here driver program, here worker node. Worker node. Okay. Executor. Task. Multiple executor, right? Task, you say. Worker node. One more worker node. Executor. Task. In this way, I'm saying dot many worker nodes, number of executors, number of tasks. So this cluster manager is going to allocate the resources, right? Cluster manager allocates the resources, instructs the worker node to execute the job. So who is going to instruct, allocate and instruct? Cluster manager to execute the job. And cluster manager will keep track of all the submitted jobs and the reports. Okay, here cluster manager. So here, okay, here, okay, this is what here you see DAG scheduler. For whenever you say action, right? Spark session or Spark context. As the action encountered, it will create the job. As the action is encountered, then it will create the job. So here, if you see this DAG scheduler, or DD1 or DD2. Or DD2 or DD3. So in this way, this DAG scheduler so what DAG scheduler is going to do, splits the graph into stages, splits it into stages, right? Splits the graph into stage. Should have seen while submitting, when we have also when we are doing the practical, should have seen stage. I was saying, right?
Yes.
I'll be
Yes.
explaining about the
In
stage and
Unix
task.
environment, yes.
Okay, DAG scheduler, RTD1, RTD2. So here, what DAG scheduler, it divides into stages and tasks, and submit each stage as ready to task scheduler. Okay. So here, these stages are created here, stages and tasks. You know about stages and tasks, right? How the stages are created and what do you mean by tasks, and how many tasks, how many executors, and how many partitions, everything, right? Yes. So this is what the entire thing, right? Entire how the job, Spark job executions. RTD splits into partitions, and each node operates on a partition. Each node operates on a partition at any point in time, right? Executing on a partition of an RTD. These operations, right, composed together, and Spark execution engine views this DAG. Okay. And fine. And last, yesterday, like I got one query, right? What is the use of Spark and what is Hive and how Hive and Spark SQL are different, right? Hive and Spark SQL. Why we need to integrate Spark and Hive? Hive is built on top of Hadoop. Moreover, Hive is an open source data warehouse system, right? It helps for analyzing, querying large data sets stored in Hadoop files. So main advantage of Hive is a kind of data warehouse kind of environment, right? Where it is, we can perform Hive main purpose, querying large data sets. We can perform querying large data sets. Hive is the only component in Hadoop where we can perform querying. It can process the data, we can perform querying, we can make the data structured, we can create tables. It can integrate with different external sources like NoSQL. It can, with Spark, it can integrate with MongoDB, with Cassandra, with anything. Hive can be integrated, right? Got many. Okay. So, but backend, Hive backend is MapReduce. MapReduce job is going to execute. So, in case of Spark SQL, right? First, okay, Spark SQL for structured data processing. So, it's Spark SQL follows MySQL kind of SQL, right? Okay. So here, how this interaction in Spark SQL, mainly data frames. So Apache Hive, this Hive was released in the year 2012. Previously, there was no that MapReduce is mostly used. Spark SQL in the year 2014. Hive, generally, if you say Hive is originally developed by Facebook. Hive is developed by Facebook, but that Facebook later donated this Hive to Apache Software Foundation. Who is the founder of Hive? Facebook. Originally Hive was developed by Facebook. So Facebook, it has used Hadoop, and Hive was developed by Facebook, and later it was donated to Apache Software Foundation, and thereafter Apache Software, it is maintaining Hive. And Spark SQL is, since the beginning, it was maintained by Apache Software Foundation only. Apache Hive, right, supports all operating systems, VMs. So if you see data types aspects also, it has predefined. Hive has got predefined data types. But the advantage of Hive is we have got partitioning. In Hive we see partitioning, right? In Hive we see partitioning. Daily data is coming. I want to create one partition, I can create in Hive. I want all Hyderabad data as one partition, Pune data as one partition, Chennai branch as one partition. I can create partitions in Hive. Static partitioning, multi-column partitioning, dynamic partitionings. In Hive, the advantage, partitioning methods are the advantages, right? In Hive, I no need to query the entire lakhs of data, right? If 50 lakh records are there, no need to query all the 50 lakh records. I want only particular city. For example, I Pune records. Pune records are only 500 records. Out of 50 lakh records, you're just only, you're querying only 500 records only. Means nearly 95% you are skipping, right? You are skipping only 5%, you are scanning. Instead of scanning the entire thing, you are just scanning only a part of it. So daily, if data is coming, daily, I can create some kind of partitioning, right? And I can just perform these things. Querying can be performed in Hive. As Hive has got MapReduce, right? And also we have got in another feature, like in Hive, we got partitioning, bucketing concept also available, right? Hive partitioning, bucketing. And processing in Hive, right? We have got like some kind of a weblog data, XML data, and that also in a simpler manner we can process it, right? So even Hive has got, that's the reason Hive has got a lot of advantages just for data warehouse processing if you want Spark. But when we integrate, I said in the last class how Spark and Hive is integrated. When I created some Hive tables from Spark itself, go and check in the Hive, the tables got created, right?
Yes.
The previous sessions, right? I created
Yes.
some tables, Hive tables I created from Spark side. I just closed Spark and opened Hive, right? We can see all those tables, databases, everything available. At the back end, MapReduce processing happened or Spark processing happened when I was creating Hive.
It's actually MapReduce processing happen.
No. When we are performing in Spark, there is no concept of MapReduce in Spark. When I am creating Hive tables in Spark, how MapReduce comes into picture?
Yeah, Spark MapReduce is not. I mean, Spark.
So internally, Spark reduce. What is that? Spark processing is going to happen while creating Hive tables internally. Spark processing is going to happen, but generally in Hadoop, when we are creating Hive tables, MapReduce execution happens. But I'm creating table with Spark execution, Spark processing happening, right?
Yeah, but it will do a Spark processing, but it will still store the data on HDFS.
Yeah, anything data, everything stored in HDFS
So
only, right?
yeah, yeah.
Yes.
And then once you create those tables from Spark, and you come to Hive and you, do some operations on those tables, then it will becomes a MapReduce job.
When you want to Hive, you're talking, right?
Yeah.
Yes.
When we switch, means we created a table from Spark and it got created, and now I want to do some update operation on those table or whatever, sorting or whatever, and I run the job from Hive, then it's going to be a Spark MapReduce job because
but yes. One thing, when you perform any insert command, when you perform insert override command in Hive, right? So
correct.
MapReduce processing, it's going to trigger and it is going to. But when you do the same thing in Spark, it is going to take less time, right?
Because it's all in memory. Yeah.
It takes very less time for all the processing. If you're doing Hive processing within the Spark, means I want to insert a data into the table, or if I want to perform all that SQL operations through Spark.
Gotcha.
So
Basically Hive is still a real database. It's just we can switch from legacy way of doing operations
I said
using MapReduce. We can move to Spark.
I said in the last class again, Hive metadata is stored. Hive has got its own database, Derby, DERBY, Derby database. But we can also connect to any other database, but
SQL or Oracle or whatever we want.
Whatever software I have provided to you in that and Hive metadata stored in MySQL. You see in MySQL, open and check, right? All the Hive table schema you can see. Check it. So here, whatever Hive tables you have created, for example, Control L, MySQL -u Hadoop, right? -p, and also I said Spark. I also said, right, how to create data frame directly by taking MySQL table. How to create a data frame directly without scoop. Directly Spark can read data from MySQL database, from the database, right? Without scoop. Generally scoop reads the data from this SQL to Hadoop, right? Spark. But Spark directly taking the database table and creating data frame, right? How it is reading a CSV file, JSON file, the same way it is reading MySQL table, right? Without scoop. Yes. So here, if I say show databases, whatever things you have created in Hive underscore meta, for Hive underscore metadata, right? I created it. Use Hive underscore meta. Use Hive underscore meta. Show tables, you say. Sorry, wrong, it's wrong. Show tables. TA tables, right? Yes, show tables. You can see TBLS here. Tables. Select star from. Select star from TBLS. Enter. You can see all external tables, managed tables, managed table means internal tables, external tables, which is internal, which is external. See Hive tab 2, Hive tab 4, Hive tab 5, bucketed table, sales table, partition table, bucketed, Hive tab 6. What are all the Hive tables? URL processing, sales, duplications, JSON processing, XML processing using Hive, right? All this.
So suppose to any table delay dropped, like it will be removed from the schema.
Yes, everything will be the one.
Automatic. Okay. So every table is related to linked with the schema in the.
So if you see in the hive-site.xml, if you go to the Hive installed folder, and if you see this Hive, see this 1 second. Exit. Whenever I'm saying exit, it is saying bye. Exit. So generally, if you see this Hive, right? If you see in this home, in this Hadoop ecosystem, in this Apache Hive conf folder, hive-site.xml is there. Open with mousepad. So here in this hive-site.xml, for storing this, see, I've given everything MySQL. What is this? See here, MySQL, JDBC, MySQL, and this is the port number of MySQL, where that MySQL, and this is the database within the. I created this database hive_meta in MySQL for storing all the metadata information, right? Hive_meta I have created within this MySQL, and MySQL port number, this is the database MySQL, and driver name JDBC. And what is the password? Hadoop is the password for that MySQL. And what is that username? Username is Hadoop for MySQL. Password is Hadoop for MySQL. And the MySQL port number, all the things I have provided here, right? Yes. And is where your Hive tables are getting created in user Hive warehouse. All this I have given this. By default, when you load this Hive, right, you won't see any of this. It will be an empty file. Hive-site.xml, right? It will be an empty file. I have provided this where exactly the default location, and it's MySQL and MySQL connection, username, password, everything I am providing, right? Yes. So okay, so you can just
Okay,
by
the schema
default,
means only for table, either table metadata, either every schema means
table.
or like it's not available for columns.
Everything tables, table, whatever the table, right?
Table along with schema means
Yes.
column names. Okay.
Yes, everything.
Okay, you showed only for table. Can you show the one table columns as well? How many columns are available?
So whatever method, okay. That you can check directly in Hive, right? Describe. But
okay, yeah.
But only table data is stored in HDFS. Metadata thing, everything you have seen in MySQL.
Okay. The external table, suppose we have dropped the table, the data is available in the Hadoop, right?
External table, if you're dropping, data will be available, right? Data will be available, but
only we have lost the schema.
Again, you can recreate the schema for the data.
Oh, okay, I got it. Okay,
Again,
that is advantage. Okay.
Again, if you recreate the same data, it takes, right? Okay.
Again, it will be available.
Fine. So in the last class, I said I have shown you, right, of creating of these Hive tables from Spark, right? Okay. Fine. So okay, we'll see in the next session. I'll be showing you some other things, right? It's fine. Next, so next week totally we'll wrap up the things, right? The other things, and also some other things, some which are the left out things in Spark. Fine. Okay. So I'll stop for now. We'll continue in the next. Fine.